When a standard Python script finishes execution, every variable, calculation, and user input stored in memory instantly vanishes. Without a way to save that work, your program has to start from scratch every single time it runs. We are going to solve this by building a script that creates, writes, reads, and navigates a permanent text file on your hard drive. To follow along, open your Python IDE and create a new blank script file. While computers store everything from images to audio as binary data, we are focusing on text files. These use encoding schemes like ASCII or Unicode to store characters that are directly readable by humans. This skill allows your programs to store and reuse data like employee records, sales figures, or inventory logs across multiple sessions. To begin, we use the open function. This establishes the physical link between your Python code and the permanent storage on your hard drive. We will use the with statement to manage this connection. This ensures that Python automatically closes the file and clears the allocated memory as soon as the code block finishes, even if the program encounters an error. Inside the function, we specify the file name and set the access mode to W for write. Note that this mode will create a new file or completely overwrite any existing content in a file with that same name. To add data, we use the write method. This takes a single string and pushes it into the file object we just opened. If you have a collection of strings, such as a list or a tuple, use the write_lines method to save the entire sequence at once. Python does not automatically add line breaks. You must include the new line character, \n, at the end of your strings to prevent all your data from clumping into a single line. Also, remember that text files only store strings. If you need to save numbers, you must wrap them in the str function to convert them before writing. Once the script runs, a document named myfile.txt appears in the directory containing the data we processed in our code. Using the with block and explicit write modes prevents memory leaks, keeping your data safely on disk after the program closes. To retrieve that data, start a new code block and change the access mode to R for read. The standard read function pulls the entire content of the file into the console as a single block of text. If you only need a portion of the data, readLine extracts a single line at a time, stopping at the first new line character it encounters. To keep the structure of the document, the readLines method reads every line and stores them as individual elements in a Python list. Printing these results confirms that the data retrieved from the hard drive matches exactly what we originally wrote. The write_read method lets you decide if your program handles data as a continuous string or a series of organized records. Using the R+ mode allows both reading and writing. This mode also lets us use byte offsets to move through the file non-sequentially. The tell function reports the current position of the file object. When you first open a file for reading, the object sits at byte position 0, the very beginning. If we read the first 10 characters, the file object moves forward and stops after the 10th byte of data. Executing tell again now reports 10, confirming exactly where the cursor is parked within the document. To reread that data, we use the seek0 command. This snaps the cursor back to the starting byte, allowing us to process the same information again. These functions give you random access to your data, allowing your program to jump to specific points in a file without reading it from the beginning every time. This 15-line script provides a complete cycle, creating a file, writing data, reading it back, and navigating to specific byte positions. Your code now has persistent memory that survives even after the computer is turned off. Try changing the access mode to A for append. Run the script several times to see how Python adds new information to the end of the file while preserving the previous text. Now that you can handle human-readable text, the next step is learning to manage binary files for non-text data like images and audio. This type of permanent storage is how software tracks everything from daily sales figures to individual user preferences across different sessions.